So here we have our first example with three variables. So we have these three equations here. X plus y plus 2z equals 7, x plus 2y plus z equals 9, and 2x plus 3y plus z equals 14. Now first up, do we need to rearrange any of these equations to put them into the form of ax plus by plus cz equals d? Or question mark x plus question mark y plus question mark z equals question mark. Now the truth is, all of these equations are already in that form. They have the x terms first, then their y terms, then their z terms, and then finally their answers for that, their evaluations of those. So we don't need to do any rearranging. So I'll get rid of that bit there, and we can put our values straight into the matrix. So here we have 1x plus 1y plus 2z is equal to 7. And then our next equation, 1x plus 2y plus 1z is 9. And finally, 2x plus 3y plus 1z is equal to 14. Now, myself, when we look at these, we know that we're trying to get the ones going on the diagonal from the top left. So 1 there, and 1 there, and then zeros in these other parts. So it's there, and then our column on the right hand side will end up being numbers when we've done that, and that will give us our solutions for x, y, and z. So an easy way to start is often to use the first row to make that point there in the matrix 0, and then the first row to make that first part of this third row 0. So doing that, I'll make row 2 minus row 1. So I'm aiming to make this bit here 0. So 1 minus 1 will give me 0. So the first row is going to stay the same, and the last row is also going to stay the same. And this row here is the one that's going to change. So row 2 becomes row 2 minus row 1. 1 minus 1 is 1. 2 minus 1 is 1. Sorry, 1 minus 1 is 0. Excuse my mistake there. 2 minus 1 is 1. 1 minus 2 is negative 1. And what have we got here? 9 minus 7 is 2. Cool. So remember, I'd suggested that my next step, or next good place to start, was to make this value here a 0 using the first row. So that's row 3, and that's going to become row 3 minus. Now I'm going to use row 1 to do that, but if I just take row 1 away, it's going to be 2 minus 1. So I'm going to take 2 lots of row 1 away. So 2 minus 2 times 1 is going to be 0, which is as I want it. So top row stays the same. Next row stays the same. And row 3 becomes row 3 minus 2 lots of row 1. So 2 minus 2 is 0. 3 minus 2 lots of row 1, so 3 minus 2 is 1. And 1 minus 2 lots of row 1, so 1 minus 4 is negative 3. And finally, 14 minus 2 lots of 7 becomes 0. Cool. Now what we can do, now that we've got these two zeros in the column, we know that if we do anything with these two rows, that first part is going to remain 0. So I can use these two rows to eliminate one of these points here, or one of these points here. I'm going to do it by doing this point here. So that is 1, and to make that 0, I could subtract one lot of row 2. So row 3 becomes row 3 minus one lot of row 2. So my first row will stay the same. And my second row will stay the same. And my third row is going to become row 3 minus row 2. So 0 minus 0 is still 0. 1 minus 1 is 0. Almost made the same mistake again. And negative 3 minus 1. So negative 3 minus 1 is the same as negative 3 plus 1. And that's going to become negative 2. And then 0 minus 2 is minus 2. At this point, I have made my row 3 as, well, I've got all the zeros in that third row that I want. So remember that I want 1, 1, 1 down there, 0, 0 for that bottom row, and a number here. So I want that to be a 1 still, and I can make that a 1 by dividing it by negative 2. So row 3 is going to become row 3 divided by negative 2. So any number divided by itself is going to become 1. So negative 2 divided by negative 2 is going to become 1. Now I'll put that value in now. Negative 2 divided by negative 2 is 1. Negative 2 divided by negative 2 here is 1 also. 0 divided by anything is still 0, and 0 divided by anything is still 0 as well. And I'll fill in the rest of that matrix. Now at this point, these sort of things are gold. When you end up with this, just having all the zeros and a 1 there, you can use that to eliminate any one particular point to a 0 targeted without affecting the other bits, because you've got the zeros there. So for example, if I was to use that to make that row 3 to make that point of row 1 a 0, so that 2 a 0, both of these values here are still going to stay as 1, which is quite ideal. So let's do that. Row 1 becomes row 1 minus row 3, and it's going to need to be more than just one version of row 3. So I'm going to do it with 2 versions of row 3. So 2 versions of row 3, 2 lots, 2 times 1 is 2, and then you've got a 2 up here, 2 subtracted by 2 lots of that. So row 1 is the one that's changing. So 1 minus 2 lots of row 3, 1 minus 2 times 0, well, it's going to be 1 still. Same thing over here, 1 minus 2 times 0 is 1. Then we have 2 minus 2 times 1. So 2 minus 2 times 1 is 0. And 7 minus 2 times 1 is 5. Fill out the other bits. 1. Cool. Now I can use this as well to take out, so this row 3, to take out this point here. So by adding the 2 rows together, negative 1 and 1 together are going to make 0. So here I could do row 2 becomes row 2 plus row 3. And my top row isn't changing. 0, 5. My bottom row isn't changing either. Now my middle row is, that's becoming row 2 minus, row 2 plus row 3. So 0 plus 0 is still 0. 1 plus 0 is still 1. And negative 1 plus 1, it becomes 0. 2 plus 1 is 3. So at this point I've now got another row where I have my 0, my 1 and my 0, 1. Remember I was saying that that was a gold mine when you get those points, because you can use that one value in there to target any of the others in the other rows. Now my row 1 is the only row that still has a number in that column, so in that second place along. So that's what I'm going to do there. I'm going to use that row 2 to target that second part. So row 1 becomes row 1 minus row 2. And I only need one lot of row 2 because it's 1 and 1. So row 1, 1 minus 0, then 1 minus 1, which is 0, then 0 minus 0, which remains 0, and 5 minus 3, which is 2. My other rows stay the same, 0, 1, 0, and 3, and finally 0, 0, 1, and 1. Now at this point I can read off my solution. I have 1x being equal to 2, so x is equal to 2. Then I have 1y being equal to 3, so y is equal to 3, and 1z being equal to 1, so z is equal to 1. And we call this a unique solution because we have an exact answer. So this gives a unique solution at x equals 2, y equals 3, and z equals 1. And that's how we do it. Now that is a really common way to go through one of these 3 variables sets of simultaneous equations, to drop down and do the 0, then the 0. To aim to first off make this point here 0, then this point here 0, then this point here 0, and then once you've got that you can use the 1 to make that 0, and then that 0, and then the one that you end up with here to make that 0. So it's a good way to go about things. It's not how you have to do it, but it is a good way to go about it. As you can see, it worked in this scenario.